A grab bag contains 10 $1 prizes, 5 $5 prizes, and 4 $20 prizes. 3 prizes are chosen at random. Find the following probabilities. Well, before we even discuss finding the probabilities, let's discuss what is actually being stated here. The first thing is that 3 prizes are chosen at random. So that means that there's always going to be 3 out of the total that will be chosen. We're given 10 $1 prizes exist, 5 $5 prizes exist, and 4 $20 prizes exist. So we need to understand what the total number of prizes are, because that will define how we're going to do these probabilities. So we simply add the 3 values together. So we will have 10 plus 5 plus 4. Add those together, and that gives us 19 total prizes. So when we define probabilities, we're going to use the following formula. The probability of the event, whatever that might be, is going to be equal to of the number of ways that the event can happen divided by the number of ways that the sample space can happen. Well, we already know that our sample space is going to have 19 different prizes that can be chosen. And since those prizes can be chosen 3 at a time, that means that n of s, the number of the sample space, will always be given by the following. And this is a combination, since order will not be important. It's not going to matter how I draw the 3 prizes, just the fact that I was able to draw 3 prizes. Now let's go ahead and look at which probabilities we are supposed to find. The probability that exactly 2 $20 prizes are chosen is, let's write this out so that we understand it in terms of the question. The probability that we choose 2 $20 prizes, but what does that really mean? And we're talking exactly. So that means if there are more than 2 $20 prizes in the pot, those cannot be chosen. But if we draw 2 prizes, remember that there are 3 total prizes that will be chosen. So that means we will choose one other prize, and this is going to come from the remaining non-$20 prizes. And that's going to simply be equal to the number of choosing 2 $20 prizes and one other divided by the number in the sample space. Now, let's go ahead and look at what's happening here. The first thing to examine is the fact that we have 4 $20 prizes. And if there are 4 $20 prizes and I want to choose exactly 2 of them, that means it's going to be 4 combination 2, or 4C2. And since I have 4 $20 prizes and I have 19 total prizes, so we take the 19 total prizes and we subtract from that the 4 $20 prizes, that's going to give us a remainder of 15 other prizes. So we're going to choose one of the 15 other. That also will be a combination, so it will be 15 chosen one at a time. Now, in order to do this correctly, I'm going to have to multiply those 2 particular combinations together. But let's write this out and say the probability of two $20 prizes and one other will be equal to this 4C2, and we're going to multiply that by this other combination of 15C1, and we'll divide that by n of s, which we've already discovered to be this right here. So that's going to be 19 chosen 3 at a time. In order to understand that I've got the correct values where they need to be, I want to look at the fact that this number here plus this number here will be equal to this number here. If that's a true statement, it looks like I'm on the right track. And additionally, if this number here and this number here is added together and gives me that same number there, I know that I'm on the right track. Now, this is not a total panacea, because there are going to be times where you can put figures in the numerator and they're not going to be the correct ones, but you'll still add up with the numbers in the denominator. But this will work pretty much most of the time. So let's go ahead and do the calculations for this. You can use your calculator, and most scientific calculators, if not all scientific calculators, have a combination key. I'm going to use a web-based calculator called Web 2.0 calc.com. This is the URL up here, and you'll notice that there is an NCR button here, which are combinations. And I'm going to use this to show you exactly how I'm going to enter this into the calculator. And you can, okay, so in order to enter the 4C2, I'm going to input this key first. Now, depending on the calculator you have, you may have to put the number in first, then the NCR button, then the second button. Just depends on the calculator, and you will need to read your instructions. So this will be 4, comma 2, and then I will close my parentheses. Then I'm going to multiply that by another combination, and I'm going to do this other one in the top, and that will be 15 parentheses 1 close parentheses. I said parentheses, I meant comma. And then I'm going to divide by the 19C3, so we'll left click NCR, type 19 comma 3 close parentheses, and press equals. And this is going to give us our probability of 0.092879, and we just need to round off to 3 decimal places, or the nearest, so that nearest thousandth, so that's going to be 0.093. The next probability that we're going to find is that one of each prize is chosen. So now, scrolling back up, we're going to look at this. Remember, we have 10 $1 prizes, 5 $5 prizes, and 4 $20 prizes. And 3 prizes are chosen at random, and now we want to determine what the probability is that I'll get a $1 prize, a $5 prize, and a $20 prize when I draw at random. So let's write this out so that we understand what we're looking for. We're looking at the probability that we're going to draw one $1 prize, one $5 prize, and one $20 prize. And that's going to be equal to the number of the event over the number of the sample space. We already know what n of s is. We have written this previously, but just to refresh, it is 19C3. We have 19 total prizes, and we will choose 3 at random. So now let's understand what n of e is. N of e is going to be equal to the fact that I have 10 $1 prizes, and I'm going to choose one of those $1 prizes. I'm then going to multiply that by the fact that I have five $5 prizes, and I'm going to choose one of those. And then I'm going to multiply by the fact that I have four $20 prizes, and I'm going to choose exactly one of those. That's N of E. Now let's go ahead and make sure that we have the probability stated correctly. So the probability that we're going to draw one $1 prize, one $5 prize, and one $20 prize will be equal to the following. Now remember, N of E is equal to this right here. And this is what's going in the numerator. And that's going to be divided by 19C3. Now let's just verify that I've done this correctly. I need to add 10, 5, and 4, and that should be equal to 19, which in this case it is. Then I need to add 1, 1, and 1, and that should be equal to 3, and in this case it is. So once again, we're going to use the calculator to do this because this is a very complex arithmetic that we're dealing with, or computation. Okay, so we start with the NCR, and we're going to do the 10C1 here. So 10, comma, 1, close parentheses, times. We're going to do another NCR, 5, comma, 1, close parentheses, times another NCR, 4, comma, 1, close parentheses. Now that's the entire numerator. Now we're going to divide by another NCR, 19, comma, 3, close parentheses, press equals, and we have 0.206398, but we just need to round off to 3 decimal places or the nearest thousands, so that's going to simply be 0.206. And finally, we have the probability that at least one $20 prize is chosen is round to the nearest thousandth as needed. Now when we talk about this one, this is special because it says at least one $20 prize. Now remember, we are choosing 3 prizes. So that means that there are 3 possibilities here. When we say at least one $20 prize, there's going to be the probability of choosing one $20 prize plus the probability of choosing 2 $20 prizes plus the probability of choosing 3 $20 prizes. Now, that's a lot of work. I'm going to have to do 3 different sets of calculations similar to what I did in the first step, which we already have the probability of choosing 2 $20 prizes. Rather, I'm going to go with the fact that the probability of choosing at least one $20 prize will be equal to 1 minus the probability of choosing 0 $20 prizes. And that's the complement rule. We've used that before. We're going to use it again. So how hard is it to find the probability of choosing 0 $20 prizes? Not very, because in this particular case, the probability of 0 $20 prizes will look like this. It will be equal to the number of 0 $20 prizes divided by the sample space, the number in the sample space, which we've already calculated. So let's go ahead and calculate the number for 0 $20 prizes. Now remember, we have 19 total prizes, and we're going to choose none of the $20 ones. So there are 4 $20 prizes, and that means there are 15 other prizes, and we want to choose from those 15. So N of 0 $20 prizes will be equal to the fact that I am not going to choose any of the $20 prizes times the fact that I will choose 3 prizes from the remaining 15. So the probability of choosing 0 $20 prizes will be equal to 4C0 times 15C3 all over 19C3. Once again, I want you to key on the fact that 4 plus 15 will be equal to 19, and 0 plus 3 will be equal to 3. And I can put that into the calculator. So let's go ahead and do the calculations. We're doing the first combination of 4, 0. Now remember, it's going to depend on what kind of calculator you're using, how you're going to input this, and you need to be familiar with your calculator. We're going to multiply that by the next combination, which is going to be 15 and 3. So we're taking 15 items, choosing them 3 at a time, and then we're dividing by the fact that there are 19 total items, and we are choosing those 3 at a time. And you will use the same exact process that I've used throughout this video. We'll left click equals, and we get 0.46955, which will round to 0.470. Now the probability of choosing at least one $20 prize is going to use the complement rule, and that will be equal to 1 minus 0.470, which will be equal to 0.530. And finally, we have the probability that no $1 prizes are chosen is. So once again, remember that the sample space, the number in the sample space, is equal to 19C3. And we also need to remember that there are 10 $1 prizes, 5 $5 prizes, and then finally there are 4 $20 prizes. And we want to find the probability that no $1 prizes are chosen. So if there are 10 $1 prizes and I don't want to choose any of those, I can use 10C0, which means that there are 9 remaining prizes, and I will use 9C3. So the probability of no $1 prizes will simply be this: 10C0 times 9C3, and we divide that by the sample space, the number in the sample space I should say, 19C3. Once again, let's just double check. Does this number and this number add up to this number? Yes. Does this number here add up to this number here? Yeah. And does this number plus this number add up to this number? Yes. So once again, I can use my calculator to determine what this value is. Alright, so let's start with NCR, and we're going to do 10, 0. We're choosing 10 items, 0 at a time. We're going to close the parentheses and multiply by the next combination, which will be 9 chosen 3 at a time. Close the parentheses, and then I'm going to divide by the sample space number, which will be 19 chosen 3 at a time. Close my parentheses and left click 0, and I will have 0.086687. We'll round to 3 decimal places and get 0.087. And notice that this is a very small number. And that should make sense, because since more than half of the prizes are $1 prizes, it would be extremely unlikely that none of the prizes drawn will be just the or I should say, will not be any of the $1 prizes.